Welcome to Math 1314. This is section 2.4. We're looking at lines. So, looking here at question 1, we are given a line. They might say, well, how do I know it's a line? Well, look at the powers on the x and the y. There's no exponents, there's no radicals, there's nothing strange, there's just x and y. So that tells me it is a line. But it's not in a really great format that I can tell you too much about it. So let's look over here. And what if I isolate the y? Alright, so I'm going to bring the y to the right, and I'm going to bring the number to the left. By doing so, I get it in a form that looks like y equals mx plus b. Alright, so when it's in this form, y equals mx plus b, m is the slope. Alright, so that tells me something about the line going up and down. And this number tells me exactly where it is crossing on the y-axis. So I know this line is going up and it's crossing at 0, 4. Alright, so let's take a look at that. So here's 0, 4. Now if I'm looking for the x-intercept, how do I get that? Well, I simply set y equals 0. So here's the y equals 0. And so now I'm going to solve for x. So I move the 4 to the left, making it a minus 4. And now to get rid of the number in front of the x here, divide by 4, and I get x is minus 1. And so that's where it is crossing on the x-axis. Line is going up. If you want to, you could even use the slope because it's over 1 and up by 4. Slope was rise over run. Alright, so here's my line in the first question here. Alright, and then they asked us about the x and y intercepts. In question 2, we have a special form of a line. Notice there's no y. There's just x and a number. Whenever you have the case that you see x equals a number and you know it's a line, then it's only of one kind, and that is it's a vertical line. And vertical lines, the slope is undefined. It's very steep, so it's undefined. And the x-intercept is where the number is. Okay, so in our case, the x-intercept is sitting here at minus 2, 0. It's a vertical line crossing at minus 2. So again, it's easy to recognize because there's only an x, there's no y. And it's one of our special forms of a line. And this one has no y-intercept because it never crosses the y-axis. Alright, and so you would just enter none. They tell you here in Connect Math, enter none if it doesn't have one. And so we didn't have any. Alright, what about question 3? Alright, well, question 3, we do have an x and a y. So that tells me my line is going up or down. So let's see, what if I divide both sides by 3 and I get y is minus 5/3 x? Well, the minus 5/3 says it's going down, and there's no number here on the end. There's nothing. So that says b is 0. So this line is going through the origin and it's going down. Well, let's see. Let's see, going down. The slope is the y on the top, x on the bottom. So you see here, if we're going down, this point here on the graph is over 3 and up by 5, giving me that this slope is a minus 5/3. Now, another way, if you didn't see that, is just to pick a nice point. And that is, I could pick a value to plug in here. And an easy thing to plug in would be minus 3. Because minus 3 would cancel this. Minus a minus is positive, putting this point at minus 3/5. So you could pick some point that's easy to calculate with. I picked 3 because that canceled. Minus 3. You could have picked positive 3 and would have worked as well. Okay. And the x and y intercepts of that, because it crossed through the origin, are both at the same spot. All right, question 4. We have a little mountain here, a hill. And the hill here is 760 feet along the horizontal, and it rises up 276 feet. So another way to think of the slope m is rise over run, where the bottom is called the run and the vertical amount of change is the rise. And so this would be 276 over 760. So we're done, except now we need to simplify this because it says exact simplified form. If I give it this number, it's going to say, well, that's not simplified. Now, since the end ends in a 0 and a 6, I know at least a 2 goes in. So I thought, well, maybe something bigger than a 2. How about a 4? So I tried 4. 4 did go into the top and the bottom, giving me 69 over 190. And that won't reduce any further, and so that is our slope. And so it is a positive slope. We are walking up. In question 5, we are looking at the pitch of a roof. All right, so we have a roof here. Here's part of our house. It's 24 feet this way, and the rise in the attic is 7 feet. And this is the rafter where they would put the shingles on the roof. All right, so, well, what's the slope of this? What's the pitch? And that is the rise versus the run. And they say here half a span. So half of the span, so half of that is 12. And so the rise is 7, so 7 over 12. And that's not reducible. All right, in question 6, we have 2 points, and I want to find the slope of the line connecting them. All right, so my slope m is the difference in the y's over the difference in the x's. Just keep in mind the y's are on the top. Also keep in mind these minuses are part of the formula. And so if your coordinates are minus, that's going to change this to minus a minus or something else. We'll see that in a moment. So here I need to take my y's and subtract them. Well, it doesn't matter which one. Which one is y1 and which one is y2. I just pick 6 and 2. So 6 and 2. What matters is that I get the corresponding x that goes with it. 3 goes with x, 9 goes with 2. And so 6 minus 2 is 4, 3 minus 9 is a minus 6, and so this reduces to a negative 2/3. All right, in question 7, they want me to find the slope of this line. There are a couple of ways to do it. One way is, first, the slope is going up, so it should be positive. If I take this point, well, why did I take that point? Well, because the graph doesn't cross any other point nicely. So I picked that one, and doesn't cross anywhere nicely here. By nicely, I mean at a grid point. So it does cross there. And so what I see is I go over 3 and up 2, so the slope is 2/3. Or I could pick the 2 points, -2, 2, and 1, 4. So let's see, 4 minus 2, 1 minus, see, here's what I was talking about, the minus connecting them, and here's the -2, so minus a minus is a plus. And so the slope of that line is 2/3. All right, let's see. Question 8. Find the slope of this line. Well, let's see. It is going down, looking from left to right, so it is going down. It's coming through the origin. I can see that. It's crossing all these grid points, so I should be able to pick something easy, and I'm going to pick -1, 1. So again, I can use my 2 points to find the slope, or you could think of this as going this way 1 and down by 1. And so the slope is -1, and it is the downward diagonal line. Let's see what other fun we have. All right, in question 9. Oh, let's see. I see this blue line here. It's perfectly flat. Oh, I remember horizontal lines. They look like y equals a number, and their slope is 0. They are flat. Okay, slope is 0. Now I could pick 2 points and actually look at that. 1 minus 2 and 2 minus 2. So you can see, why is it 0? Well, because they are the same y. There's no up and down on the y. The top part is 0. 0 over 1 is 0. What would the equation of that line be? I wonder. Well, the equation would be y equals -2. So x equals a number is vertical, y equals a number is a horizontal line, and the number is where it's crossing on the y-axis. Let's see. Question 10. Determine the slope of the line. Well, looking at this line is perfectly vertical, up and down. So vertical lines are of the form x equals a number. What number here? It's crossing at 3. So the equation of this line, they didn't ask us that, but it would be x is 3. The slope is undefined for vertical lines. Why is it undefined? Well, let's see, there is a change in y. 2 minus 1 is 1. But notice there's no change in x's, and 3 minus 3 is 0, and 1 over 0 is undefined. So the slope of vertical lines is undefined. They are of the form x equals a number, and the number is exactly where it's crossing on the x-axis. Let's see, question 11. Use slope-intercept form to write an equation of a line that passes through the point they're going to give us and has the proper slope. All right, so let's see. Here is slope-intercept form. What I need is a slope and a y-intercept. And look, they gave it to me. Slope is 4/3. Okay, plug that in. And they gave me the point 0 minus 7, and that is a y-intercept. So therefore, my equation of my line in slope-intercept form is 4/3 x minus 7. Alright, and they want us to write it in function notation, which all I did is write the y as f of x. Alright, and in our last question, they say find the slope of a secant line. Well, don't let that word bother you. All they want us to do is find the equation of the line in red. They're giving me a curve, and they're giving me 2 points on the curve, and they say what's the slope of the line connecting them. Okay, well, let's see. There are a couple of ways to do it. I could look at it how far over and up. Well, let's see, that's 2 over and 6 up. 6 over 2 is 3. Or I could use my points. 8 minus 2 is 6. 3 minus 1 is 2. 6 over 2 is 3. Line is going up, so the slope should be positive. That agrees with what we found. And that's the end of it for section 2.4.